Good afternoon, everyone. My name is Rachit. Welcome and thanks for joining in today, where I'm going to talk about Spark performance tuning when we are running Spark on containers or on Kubernetes, right? So I was supposed to give this talk with my co-presenter, who is our performance architect, but unfortunately he is not able to come. So I'll cover his part also. Uh, so uh, Before I begin, just about myself. So I'm a lead software architect for IBM Cloud, where we are building services on IBM Cloud. And currently I am leading a team where we are building Spark and Hadoop as a service. So we have two flavors of this service. One is offering managed Hadoop and Spark clusters, and another is a serverless offering where you get open source Spark only in few seconds, which is running on Kubernetes, right? And we have been running this service for past 6 to 7 years now, and we have experience of running services on pure containerized workloads on bare metal, which we used to do like 5 years ago. And now we have transitioned our services to make them run on Kubernetes. So from past 2.5 years, we have been running these services on Kubernetes. And we have infrastructure like in 16 regions across the globe. We have around 50 Kubernetes clusters of 50 nodes each. So we have like the experience of using Kubernetes at that scale and the problems we encounter and how we fix them. So this talk is going to cover not only Spark, but some aspects of any clustered application running on containerized environment or on Kubernetes, what you should do and how you can improve on things, right? So some more things about myself. So I'm also writing a book, which is like algorithms in big data. So the attempt is to give you an idea that how you can start your big data journey. So this book is for the newbies or the people in college who wants to get started on big data. So before I begin, like, how many of you are already familiar with Spark? A few of you. And how many of you are familiar with Kubernetes? Almost all. So just a quick introduction for people who don't know about Spark. So Spark is an open source, scalable, massively parallel in-memory execution engine for your analytical applications. Think of it as an in-memory layer which sits on top of your nodes, and it pulls the data from various sources, right, and keeps it in memory for doing the analytics over your nodes in your cluster, right? So Spark gives you hundreds of operators which are meant to do operations like I/O operations or the scheduling operations, and it comes with a lot of libraries which gives you capabilities of doing SQL processing, graph and algorithms, or it also you can have machine learning algorithms which have been specially written to do analytics in parallel, right? So Spark also includes like bundles, which gives you ability to program in the language you want, like Java, R, Python, or Scala, right? You can run Spark on your laptop or on cloud or in a standalone scheduler, or you can run it on production-grade schedulers like Yarn, Mesos, and very recently introduced Kubernetes as its resource scheduler, right? So you can read your data for your Spark from various sources like object storage, Hive, Cassandra, HDFS, or any other Hadoop data source. Right? So just to give you an idea how a typical Spark application looks like, or a big data application is looks like. So your data is coming from various sources. So you ingest your data from various sources, and then it's a role of a data engineer who prepare your data in a right way. So you may have the right data with you, but it may not be in the format that it's ready for analytics. right? So your data engineer will basically format your data and bring it in a right interface that it's consumable by a role of a data scientist, right? So data scientist is primarily responsible for building those predictive analytical models, right? And he will use this data created by the data engineer to build the analytical models, and that can be used by an application developer to write applications like chatbots, which are interacting with your customers to get more insights, right? So just to go in one level detail of a data scientist. So what as a data scientist you are really looking to do? So as a data scientist, I just want to run some analytical jobs. I want to do social media analytics, text analytics. I want to run Spark jobs or R scripts, right? I want to improve the performance of my Spark job by analyzing the daemon logs or seeing the history server events. But I'm not interested in the cluster level administration, right? But as a data scientist, if I have to set up the entire Spark cluster on my own, on my on-premises, what are the activities I will typically do? So I'll start with acquiring hardware. So I need to have the right set of hardware, which has a mix of nodes for memory-intensive nodes, and then I will prepare those machines. So by machine preparation, I mean that you will be doing disk mount operations, you will be partitioning your disks, and you will be setting up your networks. So you need multiple types of networks. You will need a management network so that you can do admin operations. You will need a network, private network for between the node, intra-node communication. So once you have set up your network, you will try to install Spark on top of it, and you will see that many a time those installation will fail. So those installation will fail either for some missing dependency or some network issue or bad disk. So you will fix those problems and try again. After multiple retries, you will be able to install and set up that monolithic application on pure hardware or bare metal or VMs, right? So, and then once you have installed your application, you will need to keep managing that cluster. You need to apply patches, you need to apply security patches, you need to upgrade the versions. So there's a lot of manageability activities even after installation, right? And you also need to worry about the high availability of your cluster for your production workloads. So with the increase in demand of analytics in your organization, you will look for some virtualization solution, right? Which will help you do all these steps in a repeatable fashion. So you would have created some VM images, which will help you install applications like Spark in a repeated manner, right? But still you need to worry about the network, you need to worry about applying patches, you need to worry about the high availability, right? Then at this point, you will consider using a managed cluster offering from one of the cloud providers. There are many cloud providers like Amazon EMR, AWS SD Insights, IBM Analytics Engine, Google Data Proc, which gives you Hadoop and Spark as a managed cluster offering, right? So that will solve your various problems. You don't need to worry about hardware, you don't need to worry about networking, but there you need to worry about scaling your cluster according to your need. At some point, you will need more of compute, and at some time, you will need very less compute. And you will be paying for that cluster even if you are not using it, right? So basically, as a data scientist, I'm looking for a serverless offering where I can request for a dedicated runtime, right, which can come in few seconds, and I'm not paying for that runtime all the time. So we have one such offering at IBM, which is called as IBM Watson Spark Runtimes, where you can connect using Jupyter notebooks, and you can request for a Spark runtime, which comes in few seconds. And this offering is running on Kubernetes, and you can request for, like, I need so many executors of Spark of a particular size and a particular Spark version, right? And So that runtime will be created at demand, and this is a dedicated runtime you get, right? Not like a multi-tenant Spark cluster where you get an instance out of a Spark cluster, because there you will see the problems of noisy neighbor and that cluster being a bottleneck for your Spark workloads. So now, when we are running this offering on Kubernetes, what really Kubernetes brings value in, right? So Kubernetes is an open source portable platform for managing the containerized workloads. This facilitates, like in a declarative fashion, you can define your application and helps in automation, right? So with Kubernetes, I get the choice of using the type of hardware I want, the type of persistence I want, because it supports the large list of persistent volume claims, which I can use for my service. And why we should think of running application like Spark on Kubernetes, it makes sense when you want to mix your analytical workloads, like Spark workloads, with your non-analytical workloads on same hardware. Let's say you have one Kubernetes cluster, and in the morning you are running it for your regular activities, and your microservices workload need more compute at that time, and maybe in the evening you want to run some analytical work jobs. You can make use of the same Kubernetes cluster to run Spark jobs on it. So you are actually utilizing your resources optimally, and which helps you in reducing the cost. So when you have decided that you are going to run Spark on Kubernetes, and what are the various options you have, right? So you can choose to run Spark on a Kubernetes in a standalone manner. So by standalone manner, you actually create a full-fledged Spark cluster running on Kubernetes, which gives you its own Spark master node, Spark worker nodes, and there are pods running for those daemons. And within those pods, your driver and executor programs will also come in, right? So there will be a Jupyter gateway pod if you are looking for interactive queries, and that will link to your Spark cluster to run actual your notebooks, right? And you will be mounting some persistent volumes on those pods, and this is how you can make use of running Spark on Kubernetes in a one way, right? The problem with this approach is that the Spark master and the Spark worker daemon, it uses extra memory and CPU, which is not really required, whereas you are just looking for running your executors and drivers, right? So this is where community worked very hard, like Kubernetes community and Spark community came together, and they built this Kubernetes as a resource scheduler for Spark, which is a more native way of having running Spark on Kubernetes, right? With this approach, you just do a you just request Kubernetes API server to give you executors and driver pods, right? You use Spark submit, and you give your job to the Kubernetes API server, which schedules the driver and some executor pods for your Spark application. And industry has done, like the community has done very good job to give you the same feeling of using as you are working on a Spark cluster. You get the Spark UI, you get ability to run a shuffle service, but still there are some missing pieces, like dynamic scheduling is still not supported if you are trying to run or more natively on Kubernetes. There is one more option, like it's a 2+ option. Like once you want to make use of natively Kubernetes scheduler, but you want to make use of Kubernetes declarative way of defining things. Like I don't want to use Spark submit to submit my application. I want to declaratively define my Spark job in a YML and give it to Kubernetes so that it can run that job. So why you need to do this is that if you have a pipeline already in place, which you can create various pods and which can define various other services in Kubernetes. Same way you want to define your Spark job, so you can make use of this is Spark operator. So what is an operator? Operator is something which manages the lifecycle of a custom resource definition. So what we have done is that we have created a custom resource definition of Spark job and created in form of an operator. And you can declaratively define your application and run on Kubernetes. There is another option where many people are trying to run Yarn on Kubernetes to make use of Yarn queues. So this approach has its cons, that why really you need a Yarn in between when same things can be done by Kubernetes layer. But people are doing it because many of the Hadoop ecosystem components don't understand Kubernetes yet. But we are making changes in open source that those components can natively work on Kubernetes, and Yarn can be totally eliminated out of it, right? So what are the things or the points which you need to take care when you are running Spark-like application or any clustered application on Kubernetes? So first thing is that you want to bring down the bring-up time of such applications. When you are trying to run a Spark job, you expect that Spark job should get running immediately on the Kubernetes infrastructure. And you don't have to wait too long for that job to go into running state, right? So, and typically when you are running Spark along with data science, the image size is very huge, because the data science packages like Conda packages are in range of 5 to 6 GBs, and it takes a lot of time to pull those images to your cluster. So what you may want to do is like run a daemon set which has all the images pre-pulled on your cluster, and then you can bring up your Spark job immediately without waiting for the images to be pulled, which may take about 6 to 10 minutes to pull it from your registry. And if you have a very small Spark job, like 2 to 3 minutes jobs, it does not make sense to pull all the time those images to your cluster, right? And if you, when you start using these applications like Spark, you will feel that your driver is taking too long to come up. That may be the case that you have given very less CPUs to your driver pod, and you may want to increase the CPUs to your driver. So we have seen that if you give like 500 M to your driver, it may take about 30 seconds for your driver to be running. If you give 1 CPU or 1.5 CPU to your driver, it may come in 5 seconds, right? So once your Spark job is running, next thing which we'll do is like you will try to read data from some remote source. So you may want to read data from an object store or a S3 bucket, right? So typically what I have seen is that people try to mount those remote locations as a POSIX file system. So that is something which is not recommended, because if you are doing some write-intensive workloads, your job will be very, very slow, because the block storage or the object storage write things in a block. So it's recommended that you make use of something called as Strokator, which is an open source tool which works very well with Spark and object store and S3 buckets. So what it does is that it caches your data to be written in your memory or in your file cache, and once its full block size is ready, then it commits to your backend store, right? So I have a blog written which can help and get more information if you're looking for how to make use of Strokator in Spark application. And for when you're trying to read from your remote source, we recommend using something like Alexio, so which is a virtualized distributed file system. What it does is that it pre-fetches a lot of data from, and it has a lot of intelligence that you are reading this file, which has so many blocks. So it pre-fetches some of the next blocks for you so that your application performance can improve, right? So with use of LXU and Strokator, you can certainly improve your application performance by 20 to 30%. So, apart from reading the job, you may also want to tune in your CPUs, which you are providing to your executors. It's very important that you should not have two small executors, like of 1 CPU or 1 GB. So what will happen is that you will have too many executors, and there will be a lot of data exchange from one executor to another. And there will be a lot of shuffle data which needs to be shuffled from one executor to another. So you will be spending a lot on your network traffic. And at the same time, you should not have executor size too big so that it cannot fit in your Kubernetes worker node, right? And if you have executor size too big, let's say of 64 GB memory, your Spark application can slow down itself because it's not able to do the garbage collection of that big size of executors. Right? So you may also want to maintain a ratio of your CPU to your memory for your executors in range of 1:3 or 1:5. In between that ratio, if you are running your executors, your applications will perform really well. So some of the other tunings which you can do in your Spark application is that you may want to set your heap memory size, which the default values are set for very small applications. But if you have huge volume of data to be read, you may want to set the Spark heap value size. It's also recommended to use native and primitive data types when working with Spark, and instead of using Scala or Java types, because those consumes more memory rather than native types. And if you are making use of native types, you will have more memory available for your application and for your Spark cache, right? And if you are you need to do a lot of serialization activities. By default, Spark comes with a Java serialization layer, which is not very good or efficient, but there is a Cairo serialization, which is recommended when running Spark for these kind of workloads. So if you're trying to use Python to make work with Spark, like in a Jupyter Gateway scenario, where you are running Jupyter Gateway also in the same pods, you may need to give separate CPU resources to those processes, because they also need a lot of CPU. And if you look at the nmom graph of Python running in Spark, you will see that there is a lot of CPU being used by the Python processes, whereas your executors are getting less CPU, and if you don't give dedicated CPUs to your Python processes. There is also recommendation to use Apache Aero if you are doing a lot of transformation from Pandas data frame to Scala data frame, or R data frame to Scala data frame. So what Apache Aero does is that it's built to transform your data and read it from a memory and transform from one language to another. So you don't have to copy your data again when you're trying to create Pandas data frame to Scala data frame. You can make use of Apache Aero to improve the performance. So apart from this Spark side of improvements, you also need to see that if you are using giving CPU to your driver size, there are some activity, although Spark is written in a way that it do a lot of stuff in parallel, but still there are processes which run sequentially. There is a process called as Spark Optimizer, which kicks in starting of each job, which basically lays down the architecture of your entire job. But it's a single threaded process. So if you are not giving good amount of CPU, you will feel that there is a lag in your job. So you need to give more CPU to your drivers for this reason. And there are many Python processes like libraries like Pandas and Py. They are not written in for the parallel workloads. So you need to give more CPU to your pods if you are having more workloads like that. Then you also need to consider the network bandwidth when you are scheduling your pods. If you are scheduling all your pods to one machine, you may be choking the network bandwidth of that machine, and you may want to spread your workload so that your network is not becoming bottleneck. You may also want to consider whether you are going to run on bare metals or on pure VMs. If you are running on bare metals, you can leverage better performance in comparison to VMs, mainly because bare metals come with better network and better CPUs. Along with, you also want to consider using SSDs for some of the disks you are going to mount for your Spark applications. Then one important consideration you need to keep in mind is that you need to upgrade your Kubernetes cluster very regularly. And if you are having long-running Spark jobs, you need to maintain proper a service to help you upgrade your Kubernetes cluster. Right? If you're, because Spark driver is not HA, and if you have a long-running job and you need to upgrade your Kubernetes cluster, there's some extra service which you need to run to manage the high availability of your Spark job. Right? So that is a point you need to take care. So one additional point you need to take care is that the default Kubernetes scheduler is not very good right fit for running your Spark workloads. You may want to change the scheduling strategy of your executors depending upon various use cases you have. At some points, you may want to pack your executors, and at some points, you may want to spread your executors. You may want to pack your executors on CPU or memory or on network, right? Or you want to consider your entire Spark application as one gang. So schedule the entire gang or don't schedule at all. Right? So there are additional Kubernetes schedulers available which can help you do all this, but you need to either buy them or build your own scheduler and plug it into the Kubernetes infrastructure. So Kubernetes is extendable to that point that you can add your own scheduler. So what are the basic learnings we have? So Kubernetes is helping us to ease down our Spark analytics. Kubernetes is not only mantra to achieve all the goals we have of running analytical workloads. So we need to design our artifacts in such a way that we can get better performance and better leverage from Kubernetes when running Spark or any other clustered application on top of it. So I have some references for you if you want to try IBM Watson Studio, IBM Analytics Engine, or you want to learn more about Alexio or Apache Aero. You can click on these links and try out various things. That's all. Thank you.